and welcome back. Today we're going to be discussing Chapter 21, and which is all about chemistry again. So, yep, we're backpedaling into chemistry. We just got done talking about Chapter 19 and Chapter 20, and that lends us perfectly to discussing some chemistry, especially with pH balances and everything. So we just got done talking about the kidneys, which is responsible for filtering a lot of our interstitial fluids, so that way we can get out any waste products or anything else that isn't serving our body at the time. So we're going to talk more about what are interstitial fluids and why are they important and how they circulate and how they're controlled. And then in the second half of this chapter, we're going to talk about pH balance, which is something that happens between our respiratory system and our urinary system and how we maintain it, because I did mention in both those chapters how important it is to maintain that to maintain that very narrow range of pH that we keep our blood at, so we're not too acidic or too basic, because then we can die, and that's not cool. And then we're going to talk about all that fun jazz. So that's what we're in for on this chapter, in Chapter 21. And just think, Chapter 24 is our last chapter, so we're basically 3 chapters away from the end. Anyway, let's go ahead. So, one more time, with feeling. Homeostasis is the regulation of an organism's internal environment to maintain conditions suitable for survival. So today we're talking about homeostasis in relation to water and electrolytes. And what are electrolytes? And is smart water good for you? Is Logan's new, what is it, Prime? Is Prime good for you? Actually, Matt Pat of Game Theory did a really, really good deep dive into sports drinks, which I'll touch on a little bit here. Very informative, very good. So anyway, so bodily fluids are not uniform throughout our body. Instead, there are different regions or compartments as we have a closed circulatory system. And there are 3 compartments overall. There's intracellular fluid compartments. This is all the water and electrolytes that are found in your cells. There's extracellular fluid compartments, which is all the plasma and electrolytes that are in your tissue spaces, plasma, lymph, etc. And last but not least is the transcellular fluid, which is your cerebral spinal fluid of your central nervous system, the fluid in your eyes, your humerus vitae, and your synovial fluids in your joints, which are good because, if you run and you didn't have synovial fluids in your joints, the friction between the bones, even with the cartilage protecting it, would actually, your knees would burst into flame. So imagine without synovial fluid, the Olympics would get really interesting, and not in a good way. So anyway, all the fluids are just really electrolytes dissolved in water, but the composition is different. So again, if you look at your intracellular fluids, like those found in your cells, you'll see that you have a lot more potassium going on in there versus in your blood plasma, you have a lot more sodium, and a lot less potassium, a lot less magnesium, a lot less protein. And again, inside you got a lot of protein and magnesium, which is interesting. So anyway, so as you can see, inside the cell versus outside the cell, there's some differences. But also, basically, remember those gateways we talked about last semester, or if you had, whoever you took this class with last semester, the potassium is in the inside of the cell, sodium's on the outside of the cell, so that way it's always set up for, especially in our nervous system, for those waves to trigger. So that way we can do the thinking and the moving and all sorts of things, and like knowing that you've stepped on something wet in a sock, which is the worst feeling ever, is, you step in something wet and you're wearing a sock. Well, I think that's almost worse than stepping on a Lego. Because at least with Lego, you go, ow, and then you get your foot off of it. In sock, you have to go take your sock off. Anyway, I have a lot of little videos on this. This one goes over fluid exchange in the tissues, which is basically the lymph system, getting, all that fluid back into your circulatory system and whatnot, so that way it's not pooling in any part of your body. Just a little reminder of that. No, we're not watching it. We're not watching it. All right, there we go. So there are two pressures that regulate the movement of these fluids, and the first one is the hydrostatic pressure. This is basically another name for blood pressure, or the outward force. The other type is basically, osmotic pressure, which is the pressure driving the fluids to re-enter the capillary bed. So it's basically based on, what we just talked about with diffusion across membranes. So that way there's an imbalance. There's again, the sodium is extracellular, the potassium is intracellular. Remember those potassium pumps? They're in pretty much your entire nervous system, which is, when it flips, that's what starts the whole wave that triggers down neurons and neuron, complexes. So, and remember, just like in the last chapter, water will follow salt. So if one side is salty and the other side is not, that means the water is more than likely going to flow towards its salty, because we talked about diffusion way back when. So again, chemistry is back to pretty much tell us how we run our bodies and how we get liquids moving all over the place and how we get it back to where we want it to be. So again, Bozeman science kind of goes into that of how, interstitial fluid moves back and forth through the osmotic pressure as well as the hydrostatic pressure. Again, this one's a little short one. I'll have it posted on there. No. There. I don't know why when I hit next, it just tries to play the video instead of just going forward. Anyway, so water balance exists when water intake equals water output. So this depends on two things: the thirst centers of your brain and what we just talked about last chapter, the kidneys. So where does the water come from? So remember, mostly of it is through drinking. So about 60% is from drinking or eating moist foods, which is 30%. And then the remaining 10% comes from a byproduct of oxidative metabolism, which is called the water of metabolism. Remember when I talked about, hopefully somebody talked about in 168 to you, how we actually do something really clever by combining and taking apart compounds in our body or molecules in our body. And we do that with the clever way of taking away water to make something snap together and adding water to break it apart. So remember, dehydration synthesis literally means you take two molecules and one's got an OH on the end and the other one's got an H on the end. And what does two H's and O make? Water. So an enzyme comes together, puts them together, sucks out that water molecule, and bada bing, they're stuck together. This is just chemistry. And so that water that came out of snapping those two together through dehydration synthesis is called the water of metabolism. And when we want to snap something apart, all we have to do is take that water molecule and shove it back together, and it breaks it apart, and one now side has the OH and the other side has the H. So we can snap it apart, which is why it's called hydrolysis. Hydro meaning water, and lys meaning to break down. So using water to break it down. So that's where the water metabolism comes from, is from dehydration synthesis. And most of the time, usually we use it somewhere else to snap something back apart again. But there's, water derivative from these things happening in your body all the time. Now, most of our water comes from drinking, and this is what drives thirst. There's two things: change in the volume of osmotic pressure, or, blood pressure, of the extracellular fluids. So in other words, you don't have enough pressure, means we need to fill that pressure back up by putting liquids back into us. And then neural and hormonal input to the brain. So our hypothalamus sits there and also is monitoring it and going, yeah, you thirsty, go drink something. And so regulation of water intake, and this is possibly a test question right here, the body loses as little as 1% of our total water, and instantly we're triggered to go drink something. So an increase of the osmotic pressure of the extracellular fluid due to water loss stimulates the osmoreceptors in our hypothalamus. The activity in the hypothalamus causes a person to feel thirsty and seek water, and then drinking, and the resulting distension of the stomach by water. So again, we have stretch receptors in our stomach that lets us know, that stimulates the inhibit of the thirst center. So lets us know, they drank something, we are good. And then the water is absorbed through the walls of the stomach and the small intestine. And the osmotic pressure of extracellular fluid then returns to normal, and we no longer feel thirsty. Pretty interesting, isn't it? So yeah, we lose as little as 1%, and that triggers us to go get a drink. So as you can see right here, ADH is our friend once again. So he's the guy that basically tells, remember, the kidney to either become permeable to water or unpermeable to water. And that basically makes us absorb water back if ADH is being released by the pituitary gland, and we reabsorb water. However, if it gets blocked or for whatever reason decides we don't need to, that's when the kidneys, especially the distal convoluted tubule and the collection ducts, actually become impermeable to water, and that just goes out with the urine. So we get diluted urine because we're losing water. And remember, the guy that gets in the way of ADH, which is why we have to go to the bathroom so hard when we're drinking alcohol, is alcohol. He's the one that kind of upsets the bucket here, which is kind of funny considering, as a pastime people consume it. Now, another cool thing about figuring out how hydrated you are is actually just doing a simple skin pinch. So if you ever want to know, are you well hydrated, you can do a really easy test, and that's all you have to do is just pinch your skin. So literally, you just pinch it, and then if it snaps back instantly, just like I did right there, you're really well hydrated. If you've been drinking a lot, and you can actually do this as a test, if you've been drinking a lot of alcohol or somebody has been, you can actually pinch their skin and the pinch won't pinch back instantly. See how mine goes instant? It's because I'm pretty darn good hydrated. I have a water bottle that actually blinks lights and texts me to drink water all the time. It's actually kind of cool. So yeah, I use technology to yell at myself to be healthier. I mean, what else is it good for other than doom scrolling on the internet? Anyway. Although not right now, Reddit's down. Anyway, so anyway, yeah, if somebody's dehydrated, the pinch won't snap back as fast. It actually slows down considerably, and you can actually tell. It's like, oh, well, you need some hydration, my friend. So yeah, do the pinch thing. It doesn't not a hurt. Don't hurt yourself. You just hold it and it snaps right back. It's actually kind of cool. So you can actually tell how dehydrated or hydrated you are just from pinching your own skin or somebody else's skin. So anyway, water must go out for balance to be maintained. So we lose about 60% is lost in our urine. About 6% is lost in feces, which is actually kind of interesting because this was shown in a Mythbusters episode. They actually wanted to see if you could put, there's an old adage you can, what is it? Something about putting 12 pounds of poo in a 1 pound bag or something like that. You can, because it's a lot of water, so you can squish out all the water and pack a bunch of feces in a bag, I guess. I don't know. Mythbusters had they used to test adages too. It was interesting. 6% is lost in sweat. And now keep in mind, it depends on the factors on how the weather is and whatnot. But keep in mind, a lot of people sit there and go, oh, you sweat your toxins out. And, it's good for you to sweat. The only thing you're losing in your sweat is really just electrolytes. You are not removing any toxins through sweating at all, period. And anybody who tells you otherwise needs to come talk to me. The only way you lose toxins is through your kidneys. So, yeah. So if anybody's trying to tell you, yeah, you just gotta sweat the toxins out, it's like, no. Anyway, so 28% lost in evaporation through the skin and the lungs, and all of this varies on environmental conditions. As you know, technically, we're getting closer to summer. Soon, the 21st will be upon us, and summer will be officially here. But it's been a bit slow coming, because it's been pretty cool lately. Which, some people don't like. Some people like, and I'm a person that I'd like to be melting somewhere. I like the heat, thank you very much. I know I'm crazy, but that's because I used to freeze up in the north for most of my life. Summer was like a blip. And then it was right back to being cold. So anyway, here's a cool TED Ed. It goes over why we sweat and what actually comes out when we sweat. Again, I can't watch this because I upload all this to YouTube, and then YouTube would be like, copyright flag me for reasons. And I'm like, no. So anyway. So, like the water balance, we must speak of the electrolyte balance, because this is where quantities of the molecules that release ions in water, electrolytes, gained must equal those lost. And we used to have a hard time understanding this, and this is actually where Gatorade came from. So let's turn back time a bit before I talk about anything else, and let's talk about sweat. Before World War I, there was kind of a weird interruption, and it wasn't just the world wars of the Olympics. There was kind of like the older Olympics, and I don't mean the ancient Olympics, which is, done by the ancient Greeks. There was a startup again of the Olympics as a worldwide thing, but it wasn't as it is today. And there was a marathon going in somewhere in the Midwestern United States, and it was not, like I said, if I can remember the tale correctly, cars had just been made, and a lot of racers were getting into trouble for actually using cars in the middle of races. Yeah, so that was kind of funny. But what had happened is, and that was one way you could tell that somebody was cheating, and they did get knocked out for cheating because they weren't covered in sweat, half dead. It wasn't normal back in the day, and this is, like I said, this is about before World War I era. It was frowned upon for athletes to drink water or whatnot while they were being an athlete. So while they were running, while they were doing sports, it was actually frowned upon. You weren't being a manly man or whatever. You weren't doing it right if you were hydrating. Now today, in this day and age, it's like, because we understand how our bodies work, and we were like gobsmacked, I mean, if you turn back time and we said, you don't hydrate, you out of your dang mind, you want people to die? So yeah, a lot of people died during marathons and races, running competitions and whatnot, because they didn't believe in hydrating during the race. And that's actually how we found out. One guy got disqualified. So there was a race. Everybody ran. I believe it was part of like pre-Olympics before it reformatted into the more modern Olympics we know now. And so they all, there was a race. Everybody ran. I want to say it was in Chicago or somewhere in the Midwest, but I'm not positive. I'm going to have to relook up the story again to get my facts straight. But anyway, long story short, basically 3 people died during this race, and the guy that won looked surprisingly not dead. Yeah, they just dropped dead out of sheer, again, because they weren't hydrating, and it was super hot. It was during a crazy heat wave, so not only that was going on. So like I said, 3 people just dropped dead during this race. And then the guy that won the race showed up looking awfully not sweaty and not like a disheveled, half-survived crazy person. And the judges were like, And come to find out, during the start of the race, he ducked out through some bushes on one side of the road, jumped in a Ford Model T, and had his friend drive him around to the near the ends. And he sat there and he just waited for a while, until he saw some of the people like turning the corner, and he jumped out and then went and ran and won the race. And like I said, everybody, like I said, 3 people died during this, or 3 or 2. And the rest of them looked like they were about on the verge of dying. And here he is looking as cool as a cucumber, and everybody went, yeah. Yeah, he got found out and disqualified, and the next person who got across the finish line that looked half dead won. So just goes to show, don't use them newfangled cars to go win your marathons. Yeah. Anyway, so how does this relate to Gatorade? Well, for the longest time, again, it became more and more common after that to basically sit there and say, we need to hydrate these people while they're running, but water wasn't cutting it. So just giving them water really wasn't cutting it. So it was actually the scientists down at Florida University I believe it so. Yeah, the Gators, right? Yeah, the Gators. And sorry, my idea of college sports is I like the marching bands because I was a marching band bum, but I'm not too into college sports. So feel free to yell at me in the forums on this one, and that's fine. You're fine. I get my state colleges kind of like discombobulated because I know there's Florida State and then there's Florida University. Anyway, long story short, with cheese, basically the scientists sat there and said, you know what, our football team is flailing about, it's hot down here in Florida, and water isn't fixing it. We got to do something. There's got to be something else we're losing in sweat. So they went in and they literally mopped up the sweat off their athletes, brought it back to the lab, and basically broke it down and looked at it. And I believe this was in the 50s and 60s. So they looked at it and said, oh, all these ions are being lost in the water too. Not toxins, but just ions. So they're like, wait, what if we take all these ions, which is interestingly mainly sodium, and slap it back in the drink and then give it to our athletes? Would they do better? Bada bing, bada boom, Gatorade was born. That was literally how Gatorade was born. It's named after the Florida Gators. So, because that's the university that did all this research and made Gatorade. And Gatorade's been the same since. It is literally scientifically just replacing what you lose in sweat. That's all it is. It's just flavored sweat water that we can put back in our body, and it re-energizes us more than just regular water would. And that's why it's so sugary too, because it's very, very salt laden, because that's literally what we're losing. Aside from water, is we're losing a lot of salt, sodium ions. And that's what we need to put back into our system to get our nervous system re-energized, to make our muscles re-energized for us to move around and run and do all that fun stuff in the hot weather. So now this brings me to the new thing, because a lot of people are going over and looking at, what is that, Prime and Logan Paul, who I don't have the highest opinion of to begin with, but hey, he's got way more money than me, so quite frankly, I should probably just be like, shut up. Anyway, shut up, me. You're just cranky because you're not rich, which is true, but oh well. I also not into crypto either. Anyway, so it's probably a good thing. Long story short, with cheese, Prime does taste better, I must say, but unfortunately, it's got a different electrolyte. It is not the same as Gatorade and Powerade. Gatorade and Powerade literally mirrors what you're losing in sweat, which is why it's salty. And to mask that saltiness, they put in a ton of sugar. But Prime doesn't have the same electrolyte mix, so it really isn't replenishing you. Even though it has less sugar, it's not replenishing everything you're losing when you're sweating. So, and that's the thing with a lot of the drinks, because they're trying to stand out from the OGs, you know, Gatorade and Powerade. But Gatorade and Powerade are both scientifically formulated to replace what you lose when you sweat like crazy when you're exercising. So, but Prime is not. So that's why Prime can use less sugar, because it doesn't have as much as the sodium as, like, say, Gatorade or Powerade. And not everybody wants to drink straight up salty water, which is why they dump all the sugar and flavoring into Gatorade and Powerade to make it more palatable. So there you go. So is Prime worth it? Hey, if you like the taste, go ahead, have fun. But keep in mind, it's not the same thing as Gatorade or Powerade. Now, am I saying Gatorade and Powerade are the end all be all? Yeah. I kind of like Smart Water myself. I'm a big fan of Smart Water. If I'm feeling sick or something, I just go for a nice big bottle of Smart Water and down that, and that usually helps me out immensely. I always have Smart Water around. Also helps with thirst, but it's not on the same level as Powerade and Gatorade again. So again, sometimes you just can't mess with the OGs. And Gatorade's got the science. It's got the science! And glowing sweat from all those ads in the... Was it in the 90s and the 2000s, or was it just the 2000s? Yeah. Anyway, so mostly we get enough electrolytes through eating and drinking. However, severe deficiencies can leave you for a major craving for salt. So how do we lose it, especially through sweating? basically through strenuous exercise or doing hot, muggy days, through the feces, but the bigger factor is controlled by your kidneys. Once again, your kidneys come in and pretty much tell you how to run your body when it comes to liquids like that. So basically what's going on in the over tube is basically this. So plasma potassium ion concentration increases. You have a lot of potassium. Adrenal cortex secretes aldosterone into the bloodstream. Then the renal tubules increase reabsorption of sodium in response to match the potassium. And this increases the secretion of the potassium ions. So if you have too many bananas, actually, there was something else that actually gives you more potassium than bananas. Now I can't think what it is. Oh, pumpkin seeds. Anyway, but if you say you've been eating tons of pumpkin seeds, basically your renal tubules are going to reabsorb more sodium ions and increase secretion of potassium ions. And so sodium ions are conserved, and the overabundance of potassium are excreted in the urine. Now, you can also go through this whole fun time too. I just gave you this as a quicker example if you've got too much potassium. So anyway, so plasma calcium ion concentration decreases. So basically the parathyroid glands and a couple of things goes here. So basically the renal tubules not only conserve calcium ions, but they also, there's another thing that happens in the parathyroid, tells the bones to start osteoclasts. We're basically breaking down bones to get more calcium, and then the phosphate ions are added to the bloodstream, and then the intestinal absorption of calcium ions increases. So it basically tells your intestines, hey, I want you to really specialize on sucking out as much calcium as possible. And your intestines go, yeah, boss, gotcha. And then again, the calcium should go back to normal. So this is what's going on, is we have a whole bunch of the parathyroid, which basically tells your kidneys to conserve your calcium, your bones to release more calcium, and your intestines to, make sure that we're getting as much calcium out of what we're eating as possible. And then when it increases, basically normal plasma phosphate ion concentration is maintained, and then the concentration returns back to normal. So it doesn't just do one thing. There are many different ways that our body actually detects and makes sure that the ion concentrations that we need to keep our body running is maintained, whether it be through the kidneys or through other factors as well. But as you can see, the bottom dollar here is the kidneys. One of the things that always reaches out and says, hey, we need to retain as much as this and let go of that. And the kidneys are like, gotcha. So this is one, what would happen if you didn't drink water, which is not good. We actually can live without food for a lot longer than we can live without water. So again, it's another quick TED Ed. I'd show it, but like I said, I don't really want to get flagged. Nope. Okay, I think this is the last. Yeah, it is. Okay, so with that said, that's why, ions are important. Your kidneys basically control what's retained and what's let go of your ions, and also you lose it through sweat. And like I said, you do not sweat out toxins. Your kidney gets rid of the toxins. You do sweat out ions, and then to get it back, drink some Gatorade. And hydration is manly and womanly. So everybody hydrate, unlike what they thought pre-World War I era. I'm so glad we don't live back in that time sometimes. Aren't you glad we've come so far and gone, look back in time going, you did what with what? Oh, ew. I'm so glad. So anyway, with that said, I'll see you in part 2 where we get to talk about pH a lot. And a cool little chemistry dance that happens because of your kidneys and breathing. So with that said, I'll see you in a moment.